Let's start with Chapter 1. Chapter 1 contains a lot of miscellaneous and somewhat mundane and tedious things, but I'm afraid I'm going to have to go over some of them with you. I'm not assuming that any of you have had physics before, and so I need to make sure that we're all on the same page with these basic starting ideas. I'm going to skip ahead to section 1.3, which is about standards and units. When we're doing physics, when we're analyzing physical phenomena, we make measurements. We can measure lots of different types of quantities. Physical quantities have various dimensions. The word dimensions here doesn't mean how big they are, but it means what kind of quantities we are measuring. For example, the basic quantities that we can measure in mechanics are length, mass, and time. Basic quantities of mechanics and other things like speed are derived quantities, but because you can make speed out of length and time. Length divided by time is a speed. There are other kinds of quantities like temperature and electrical current that you can't make out of length, mass, and time, but we won't be needing them for the first many chapters of our book. So I'm not going to consider them right now. When we're going to measure things, we need standard units. And the SI system, Système International, contains the standard units that we're going to use most of the time. Now, I've read this book called The Measure of All Things, and it's not for everyone. It was about the struggles involved in measuring the distance between the equator and the North Pole in the late 1700s. The French were having their revolution, and they were also coming up with a revolution in measuring things. They wanted to start fresh and have the meter and the kilogram to go along with the second as the fundamental base units of the Système International. And they decided to make the meter represent 1/10,000,000th of the distance from the North Pole to the equator. So they wanted to measure that really accurately, and it was very difficult to do in the middle of a war. They measured from the north end of France to the south end, and then extrapolated to get to the North Pole and the equator using measurements of the directions of stars. But anyway, in this book, I was astonished to read that before they set out on this project to make the SI system, they had 800 different names of units of measure in France. And it's a lot worse than it sounds, because the same names in different towns represented different amounts of distance or mass or whatever. So if you get right down to it, they had about 250,000 different units of weights and measures in France. It's a nightmare, and they almost held on to that and chickened out and didn't make the SI system. They were afraid to leave behind that nightmare of 250,000 different units because they knew it and liked it. Well, nowadays, the SI system is used everywhere as the predominant system, everywhere in the world except for 3 countries, Liberia, Myanmar, and the United States of America. That's the metric system that we're talking about. So let me make it official here. Unit of length is the meter, abbreviated with a little m. The unit of mass is the kilogram, abbreviated as little kg. And the unit of time is the second, little s. These are the base units for the SI. Of course, there are British system units as well, and we'll see them occasionally and convert to SI as quickly as possible most of the time. If you want to make a measurement, such as measuring the length of a desk, you're comparing the desk to the standard, the meter. You get yourself a meter stick, and you compare the desk to the stick in order to measure the length of the desk.